Thumbs up. Okay, great. Okay, thanks so much for inviting me. This is a slightly different group that I'm used to talking to. It might seem a little odd that Midcoast has invited me to talk about gray whales. Slightly different topic than probably most of the community presentations, but nature is all connected, and the gray whales on our coast here rely on having a healthy ocean habitat, and ensuring a healthy ocean habitat is linked to the health of the wetland and tidal habitats that Midcoast helps restore and protect. So it is all connected. It's not too abstract that I'm here, and I hope you're excited to learn more about Oregon's gray whales. I will mention right off the bat that if you attended Lee Torres's Science on Tap talk in November here at Hatfield, that parts of my talk are quite similar, but not all of it is. So if you're hearing stuff that sounds a little repetitive or stuff that you've heard before, bear with me, because there are also parts that Lee did not talk about. Also, I'll mention that I'm still pretty early on into my PhD, so I don't have that many of my own research results yet, but I am excited to share lots about the lives and personalities about our Oregon gray whales. And finally, before I get going, I'm going to be talking a lot about the gray whale research that the GEM Lab has conducted over the last 8 years, but I do want to recognize and acknowledge that there have been lots of other folks, both here in Oregon and along the entire West Coast, that have been studying these gray whales for far longer than we have. And I just want to acknowledge their hard work, particularly the other research groups here at the Marine Mammal Institute and Carrie Newell, who is based out of Depoe Bay. So with all of those introductions out of the way, let's dive right in and get us started just on gray whales in general, because it's important to understand some of the differences between gray whale populations before we can dive into our Oregon gray whales. So currently there are two populations of gray whales that both exist in the Pacific Ocean. The first is the Western North Pacific population that is primarily located along the Russian coastline and down into sort of Chinese and Japanese waters. This group is relatively small, with only about 200 individuals in that group. Then on the other side of the Pacific, we have the Eastern North Pacific population, which is a much larger population of about 16,000 individuals. Fun fact, or maybe somewhat sad fact, there also used to be a third gray whale population that existed in the North Atlantic Ocean. However, unfortunately, that population is now extinct due to historic whaling. So zooming into the Eastern North Pacific population, like most baleen whales, these gray whales migrate between winter breeding grounds, which are usually at warmer, more tropical latitudes, where they nurse their calves or give birth and mate, all the way up to summer feeding grounds, which are typically at higher, more temperate, colder latitudes where they feed. The Eastern North Pacific population migrates from Baja California, Mexico, where they overwinter for their breeding season, all the way up to the Bering, Chukchi, and Beaufort Seas in the Arctic, where they spend their summer feeding season. And up there in the Arctic, these ENP whales are predominantly feeding benthically on amphipods. So you've maybe seen photos or videos of this where gray whales will go all the way down to the sea floor. They'll scoop up big mouthfuls of sediment or mud, and they'll filter out that mud, and then they eat these little crustacean amphipods that are in the sediment. But there is this small subset of individuals from this ENP group that don't follow this traditional migration to the Arctic. And instead, they cut their migration short and spend their summer feeding seasons in the Pacific Northwest, from about Northern California all the way up to British Columbia in Canada. And in these waters, they occupy these really shallow nearshore habitats where they feed not only on these benthic amphipods like the whales do in the Arctic, but they feed on a number of different prey types also in the water column. So they're not only feeding sort of on the bottom of the sea floor, but they're also feeding on prey that's within the water column. And even though these groups, the ENP and the PCFG, are fairly different in terms of their summer feeding habitats and the foraging behaviors and their diet, in terms of management here in the US, the PCFG is considered part of the ENP. And so this really small group of about 230 whales really brings us to pose a lot of questions about them. Why do they use this range in the first place when there's so many more whales that go up to the Arctic? Why is it such a small group? Are the PCFG exposed to different stressors than the ENP whales are in the Arctic? How do these PCFG whales cope with these stressors? And the list goes on and on. So the project that I'm a part of here at the Marine Mammal Institute is called GRANITE, which aims to address these and many more questions. GRANITE stands for Gray Whale Response to Ambient Noise Informed by Technology and Ecology, which is a mouthful, so we often just say GRANITE. And the main goal of GRANITE is to understand if and how gray whales are stressed out by noise. However, even though that is the main goal, in the 8 years that this project has already been going on, we have learned and studied a lot more than just the potential impacts of noise on gray whales. So today I'm going to talk to you a little bit about how we collect all of our data on these gray whales, what stressors these whales are exposed to here on the Oregon coast, and some stories about unique whales that we have learned over the years. Some sad, but some also very positive. But before I do that, I have to acknowledge that I do not do this work alone or in a vacuum. I am part of an amazing, hardworking, and productive team, which is headed, of course, by Dr. Lee Torres, who's on the bottom left there, taking the selfie of all of us. And alongside, we have 2 postdoctoral scholars, Casey Bierlich and Alejandro Fernandez Ajo, 1 other PhD student, Clara Bird, and a master's student, Kate Colson. So now that you know all the people doing the work and you know what they look like, I'm going to take you on a little bit of a ride to go get some data. So our work begins well before our boat Ruby even hits the water. We use a lot of different pieces of equipment and technology that we need to make sure are accounted for. So here you can see our tiny boat Ruby. She's not much bigger than a truck, really. And it's typically 3 or 4 of us load up into that boat. We usually launch at a Newport. And once we launch on our boat, we are looking for one thing on the horizon, which is the telltale heart-shaped blow of a gray whale. Once we spot that blow, the very first thing we do is we prioritize taking photos of the whale or whales if there's a group of them. Because knowing the individual that we are working with is really the glue of the entire GRANITE project, since individuals may respond differently to stressful events. And they have different ages, different sexes, life history stages that can all influence an individual's health and therefore its response to a stressor like noise. Thankfully, gray whales make our job somewhat easy in that they have unique pigmentation, meaning that no 2 whales look exactly the same. So those different white splotches and dots and lines that you can see on this whale on the right is unique to that whale. That's a whale called Dice because it has this little dice-shaped pattern right here. And while it can be sort of time-consuming to go through photos, it does make it easier that we know that no 2 whales can look the same. And so a great thing about doing this sort of photo identification work is that it allows us to non-invasively track individuals through time and space. So we don't have to attach a tracker or a GPS tag or anything, but we're able to just take photos, which, you know, we don't come in contact with the whales at all. And the whale will look the same in 1990, the way it does now in 2023. Once we know who we're working with, and let me just mute this, sorry. Once we know who we're working with and weather conditions allow, we launch our drone from the boat to watch the whales from above. We do this for 2 primary purposes. One is to assess their body conditions, so to know how fat or skinny a whale is. And the second is to film their behavior so that we can see basically if they're feeding or socializing, resting, and to just get a better glimpse of the whales. The boat is rocky, so it's not always easy to catch that drone, but we're a great team that have been working together for many years. And yeah, we've really been, we're a well-oiled machine at this point. And so to give you a very basic overview of how we assess the body condition of a whale, once we have our recorded videos from the drone, the next thing we do is we extract images from the video, like the one you can see here, where the whale is flat at the surface. Once we have that, we divide the body of the whale into 10% increments from the tip of the nose to the notch in its tail. What we then do is we calculate the surface area from the 20% to the 70% lines on the body of the whale. And this surface area is then divided by the head to tail range and multiplied by the total length of the whale. Now, this calculation may seem a little complex and abstract, but it's actually more familiar than you might think, because we base this equation on the equation for human BMI. So we call this body condition metric BAI, body area index, and it's very, very similar to the human BMI, body mass index. And the beauty of this body condition metric, BAI, is that it's length invariant, which means that we can compare the body condition of whales to whales that are of different lengths. So we can compare a calf to a 30-year-old whale, and because it's length invariant, it'll tell us the same things, and we can compare across sort of age and reproductive classes. So essentially, the important thing about this body condition metric is that the larger the number, the fatter the whale is, and the smaller the number, the skinnier the whale is. So what you can see here on the right is a plot of the body condition of this gray whale PCFG group that we have flown over from 2016 all the way to 2021. So each of the colored boxes represents a different one of those years. And as you can see, the boxes sort of dip up and down across time, with 2016 in teal and 2019 in pink being two of the highest body condition years for this group. But 2021 in yellow all the way on the right has one of the lowest body condition years for this group of gray whales. So what we're now interested in figuring out is trying to understand what is influencing these differences and dips in population body condition across time. Is it because of potentially changes in the environment, because of climate change? Are whales targeting different prey as a result? And so sometimes there's years where they get fatter because they're eating better quality prey, or in other years having to compensate and eating less good quality prey. Or are these fluctuations maybe normal? Is it normal for the body condition of this population to go up and down? Or are some of these dips a potential cause for concern? As with us humans, gray whales are long-lived species, so we really do need to have several years of data in hand before we can start to make any sort of conclusions or start answering any of those questions. So now that we have this, starting to build up this long-term data set of body condition, we can start to address some of those questions. Now, as I mentioned, the other thing we do with these drone videos is to look at their behavior. We can see so much more from the air than we can from the boat, since whales spend so much of their time underwater. So when we're lucky and the water isn't too murky, then we can see some pretty exciting things. So I'm going to show you just 4 exciting clips that we've been able to capture with the drone. So what you see here is a mom and a calf, and you can see that the smaller whale, the calf, is going underneath its mother, which we assume is likely it nursing and obtaining some milk from its mother. And then you'll see that the little calf comes back up on the same side for a breath of air. The next thing you see here, you might have trouble seeing a gray whale at all through this huge patch of kelp, but you can see these perturbations in the water, those ripples. They're actually being created by the fluke of a whale, the pectoral fin of a whale as it's moving through the water, and the whale is actually trying to stay in one place in order to feed. This next video is really interesting. We don't really know what this whale is doing. It's doing a body roll at the surface. For what reason? Not really clear, but maybe it just wanted to have some fun at the surface. And finally is a video of this whale really close to these rocks. It's really amazing how flexible and maneuverable these whales are. And you can see it kind of moves its head back and forth, snapping its jaw open and closed as it's probably munching down on different kinds of prey types. So in the lab, what we're doing now is we're looking at understanding what the purposes of some of these different behaviors are, as well as what the potential energetic costs of some of these behaviors are. Some feeding behaviors may cost energetically much more than other ones. And so we're interested in understanding the sort of trade-offs between the amount of energy it takes to perform a behavior versus the amount of energy that a whale might be gaining based on the amount or the type of prey that it's able to eat because of it doing that behavior. And we're also looking at whether different individual whales are specialized in certain types of behaviors. So are there only certain things that older whales can do because younger whales haven't learned yet how to maneuver their pectoral fins or their flukes in the same way? So all those analyses are things that are currently underway, but collecting these drone-based videos have allowed us to start answering some of those questions. One of our most difficult samples to collect are the fecal samples, because here we are totally at the mercy of the whales, whether they poop or not. Whale poop really is biological gold because it's another non-invasive way for us to learn more about each individual whale's health. We use these fecal samples for a number of different things. So far, we've used it to analyze different hormone levels. So we're able to look at testosterone and progesterone. So all the kinds of hormones that the reproductive hormones that we humans have, gray whales have too. We also look at their stress hormones and their metabolic hormones to see if they're stressed out and how their nutritive state is. We've also been trying to identify what whales have been eating using prey genetics. Obviously, just because there's spatial overlap between a certain type of prey and a whale doesn't mean the whale is eating that thing. So trying to narrow down what exactly a whale is eating through the poop could be a great way to get at that question. And we've also conducted some microplastics analyses to see whether gray whales are consuming microplastics and where those microplastics might be coming from. Are they getting it from the water or the prey or the sediment? And how much microplastics are they maybe consuming? And a big part of understanding these whales or whales in general is really understanding what they're eating and where they're getting their food from, which is why we also collect prey samples and we do some habitat sampling as well. So we drop these nets into the water to get physical zooplankton prey samples, and we drop little GoPro cameras to the seafloor to see what the habitat is like that gray whales are spending time in. And the newest component of our Granite project is attaching suction cup tags to gray whales. So this video here that you're seeing, our collaborator Dave is the one in the blue shirt at the front of the boat, and he is attaching a suction cup tag to a gray whale. You see it just plopped on there. And once the tag is attached, it records audio and video, as well as includes many different kinds of sensors that allow us to see how a whale is twisting, turning, how fast it's going. And it's always really exciting when we manage to get a tag on, because it's not an easy thing to do. So we're using these tags to better understand gray whales underwater, to try and determine the energetic cost of different behaviors, and to potentially assess disturbance events that whales might be facing in our Oregon waters here. And the final data point that we collect in this project is all about the soundscape. So what are the whales hearing? These gray whales, like most baleen whales, rely a lot on acoustic signals for a number of different things, for communication, for navigation, and possibly even to find food on reefs. So loud sounds that occur in the ocean could prevent these whales from successfully using sound to accomplishing all those tasks. And they could also be a potential stressor to whales. So because of this, we deployed these two really big hydrophones, which are essentially just underwater microphones, for 5 months in the summer, from June to October, so that we're able to monitor the soundscape along the Oregon coast to better understand how sound varies over space and time, and whether we might be able to identify any sound or noise stressors to these gray whales. And I have two short soundscape sound clips that I want to play for you that depict two very different soundscapes off the Oregon coast. The first is a natural soundscape. It was recorded in the Otter Rock Marine Reserve. You'll hear some sort of gentle clicking. It's just on a reef. It's very nice. And the second one is much, much louder. It's an anthropogenic soundscape, and it's actually from a boat that's driving right above our hydrophone. So I'm going to play these, and I just want to warn, they are a little loud, so perhaps be prepared to turn down your audio a little bit. So that was the natural soundscape. That's kind of probably what whales are just constantly hearing in the background when they're here on the Oregon coast, when they're moving from reef to reef, looking for prey. But unfortunately, they're also hearing things like this throughout the day. So that one is much, much louder, not quite so nice to listen to. Probably also how these whales perceive that sound, just as kind of jarring. So what you were actually hearing there is, as I said, a boat passing over a hydrophone, and you can actually, there's parts of the clip where you can hear the anchor chain sort of hitting the side of the boat, and it creates this clanking sound. So that's what we're trying to understand with these hydrophones, is to know, are there cycles in how noisy or how quiet it is in this marine environment? Are there particular noise events that we can perhaps pick out and identify as being particularly stressful to whales? And also, are there sort of cycles in natural soundscapes? How do wind and storms potentially also factor into how these gray whales use our Oregon nearshore environments? And so while understanding the impact of noise on gray whale health is the ultimate goal of the Granite project that I've been talking about, noise certainly, unfortunately, is not the only stressor that these gray whales experience. Another big one in the Oregon environment are vessels. Obviously, Oregonians, especially here on the coast, we love to get out on the ocean when it's nice out. And there's nothing wrong with doing that. But unfortunately, vessels pose two big sort of stresses to whales, both noise and also the risk of collisions, of actually being hit. And, oops, sorry. Oh, I didn't click. So I want to tell you a story about a whale called Equal. Equal is a male gray whale who we saw on, well, we've seen a lot, but we saw him on June 19th in 2018 by Yaquina Head near Port Orford. And he looked healthy and normal, happy, feeding, doing his thing. Everything was great. But unfortunately, when we observed Equal the very next day on June 20th, we documented fresh bloody cuts on his back, which were likely from a boat strike, because they were these parallel cuts as they would be from a propeller kind of driving over the whale. We were lucky enough to collect a fecal sample from Equal on the 20th. So within 24 hours of this injury happening, since we hadn't seen any of these cuts on Equal the day before on the 19th of June, and we were able to analyze the stress hormone levels in these fecal samples, because we had fecal samples from before the event and then one fecal sample from after the event. And so in comparing the stress hormone levels from fecal samples before and after the event, we noticed that Equal stress levels were 3 times higher following the boat strike than they were before. So clearly Equal was stressed out by being hit by a boat. Makes sense, can't be a very nice experience. While this event was sad and traumatic and stressful for Equal, it actually allowed us to sort of validate the stress hormone levels of gray whales, because we were able to document this really dramatic change in stress hormone cortisol, and we can somewhat confidently link it with a known stress event, the boat strike injury, which allows us to interpret other stress hormone levels from other whales that we've collected in the past, where we haven't had this very indicative stressful event occurring. Happily, I will say Equal has recovered from this boat strike event. We've observed him many, many more times in the Newport and Depoe Bay region, and we saw him this past summer in 2022 as well. So Equal is fine. I'm sad to say that there are lots of whales that we have seen with these kind of boat strike injuries, so it's not an uncommon occurrence. Equal isn't sort of a unique case. Whales can recover from these injuries, but obviously it might add, stress onto the plate of a whale that really doesn't need any stress. It might be sick from something else, or it might not have found enough food that year. And so I don't want my message here to be don't go boating or don't enjoy the ocean. Rather, if you're an avid boater or you know others that recreate on the ocean, I guess my message is be mindful of the fact that gray whales use our nearshore waters. I think sometimes people think about whales as being, humpbacks or blue whales that are way offshore and in deeper waters. But our gray whales are really, you can come right out of the jetty of Newport and there's a gray whale right there. So and they can be sneaky. You don't know where they are, where they're going to pop up to breathe. So just drive slow, be vigilant. And if you know that there's a whale around, then please stick to the rules of staying more than 100 yards away, and it'll make everyone much happier. I'm sure most boaters, when they know that they've hit a whale, don't feel great about it. So this way, everyone's happy, everyone's not stressed, and we can all enjoy the ocean. Another stressor that gray whales experience here and along the entire West Coast are entanglements in fishing gear. We in the Gem Lab have seen many, many whales that have wounds from likely entanglements and have even documented some active entanglements ourselves. Entanglements can be stressful to whales in a number of different ways. It can obviously, if the gear that they're entangled in is heavy, it might restrict how far or how long they can dive for. It might restrict whether or not they can come back to the surface, which might limit how much they can feed or move. And entanglements could also have, even if a whale gets freed, could even have long-term impacts if the wound takes a really long time to heal, so on and so forth. So obviously, gray whales share their foraging grounds in Oregon nearshore waters with lots of recreational and commercial fishermen. Whale entanglements in fishing gear have steadily increased along the US West Coast waters, not just for gray whales, but also for humpbacks. And the Gem Lab is currently working with both fishermen and the Oregon Department of Fish and Wildlife on a research project to better understand the overlap between different whale species and fishing gear. So we're moving in the right direction. No one wants to stop fisheries. No one wants a whale to be entangled. So it's really great that these kind of two communities can work together to help solve this problem. I am going to tell you another story about another whale, as to me, it exemplifies why this research is really needed and how harmful and sad entanglements can be in fishing gear. So this story is about a whale called Roller Skate. Roller Skate is an 8-year-old female who we documented with fishing gear wrapped around her fluke, unfortunately. So this is Roller Skate and her fluke before in 2018. Then in September 2019, we documented fishing line wrapped around and deeply cutting into Roller Skate's fluke. The entanglement site looked really painful and the line was slicing deep into the fluke. And although it was extremely unpleasant for us to witness on the boat, and undoubtedly it caused Roller Skate pain and stress, she did demonstrate some pretty tough resilience when we saw her again the following year. The entangled line had amputated part of Roller Skate's fluke. So if you look at the two drone images on the bottom, you can see on the left how she has two halves of her fluke. And on the image on the right, you can see that that one half of the fluke is amputated. It's bright pink. And her diving ability was also compromised by this injury. So we haven't unfortunately seen roller skates since 2020, but that doesn't mean that she's not alive. There's lots of other places for gray whales to feed. Maybe she was somewhat traumatized about being in the area, so she's decided to go elsewhere. But again, my message here is not that crabbing is bad or fishing is bad, or we need to stop fishing to protect whales. I love eating crab. I love supporting our local fishermen. Again, my message is to be mindful, even when you as a recreational fisherman are fishing or crabbing, make sure to only put out as much line as you need. We often see lots of crab pots that have tons of excess line. That's the kind of line that, you know, whales could get tangled up in. And don't leave your pots soaking for longer than you need to. You know, put them out, get them back in when they're ready, and you can enjoy crab, whales can enjoy their crab, and both sides of the coin are happy. So these two simple things really will reduce the risk of whale entanglements by a lot. But I don't want to give the impression that all of our gray whale stories are doom and gloom. In fact, we've documented lots of exciting success stories over the years, some of which I'm going to share with you now. So I'm sure if you're an avid gray whale fan, or if you've lived on the Oregon coast long enough, you know a whale called scarback. In our lab, we like to call her Scarlet. We think it's a little prettier of a name for a whale that's so amazing and so resilient. If you don't know Scarlet or Scarback, she's very easily recognizable by this very large orange scar that she has on the right side of her back. Now, no one knows for sure how Scarlet gained this wound, although there are theories and rumors about a failed harpoon attempt in the Russian Arctic and vessel strikes, and that, you know, once Scarlet had been through this traumatic event in Russian waters, she decided to come to America, the land of the free. But that's all unconfirmed. But the thing that is for sure is that she's a really resilient, strong whale. She's been observed along the Pacific Northwest coast since 1996, where we see her here in Oregon almost every single year, where she's feeding in kelp beds and in reef areas. And besides this very obvious big, large scar on her back, she also has a very, very beautiful fluke. It's really unique. We don't see a lot of flukes like this, but it has these beautiful upward curved tips, which to me almost make it look like a heart. So I think she's a really beautiful whale. And besides that, Scarlet has given birth to at least 3 calves that we know of, although there might be many, many more that have gone unreported or undocumented. Really, the only way for us to know for sure whether a whale had a calf is for us to see that whale with the calf. And it's more than possible that, you know, we might have missed calves in a given year. Baleen whales typically have calves every 2 to 3 years. So if you're looking at the dates underneath these 3 drone photos, you can see that Pac-Man and Brown, her 2014 and 2016 calves sort of fit that pattern. But then from Brown to Rose, there's a 4-year gap. So who knows? We might have missed a calf in 2018. She might not have had a calf. She might have said, I need a break from being a mom. I'm just going to take care of myself. So those are some possibilities. It is also a possibility that she had a calf but lost it. Killer whale attacks are really common on gray whales and calves in particular. Baleen whales also are able to essentially make the decision to terminate the pregnancy if the female is realizing that she's not going to be able to gain enough weight in order to sustain the pregnancy and the calf. So there's lots of possibilities about why we've not seen Scarlet with more calves, but either way, each of the calves that we have documented her with, she's brought them back to the Oregon coast and she's taught them how to feed and how to survive. So what I want to show you now is a plot that is just Scarlett's body condition. So this is the BAI just for Scarlett across the different times that we've been able to fly or drone over her. And I'm going to sort of walk you through this plot. So on the horizontal axis, you have date as year, month, and day. And all the little dots represent the different body condition or body area index number. So again, lower numbers means skinnier, larger numbers means fatter. And the dots are color coded according to the reproductive status that Scarlett was in when we flew over her. So as you can see, we have a couple sort of reddish dots that indicate when she was lactating. So in 2016, she was lactating with her calf Brown. In 2020, she was lactating with her calf Rose. Then the pink dot is when she was pregnant. Obviously, if Scarlett had a calf in 2020, it means she must have been pregnant the year before. And then the yellow, she's just a mature female. We typically call this a resting period in between calves. Whales, female whales tend to take sort of 1 year at least off to sort of recharge, kind of regain the weight of that they've lost during pregnancy. And so what you can see here is that the fattest we have ever seen Scarlett is the year that she was pregnant with Rose. And the skinniest we've ever seen her is the early summer the following year when she was lactating and weaning her calf Rose. And it makes sense. At this time, mothers will have been weaning their calves for almost 6 months without eating anything because they fast when they're on their winter breeding grounds. So this is when a healthy female whale will be at her skinniest. So it's really interesting to sort of see how much the body condition can vary given these different reproductive status designations that female whales can be in. The next whale I want to talk to you about is called Pac-Man. She is the first known daughter of Scarlett. She's still a relatively young whale. She was born in 2014, which makes her about 8 or 9 years old now, which is about the age that female gray whales become reproductively mature. So who knows, next year we might see Pac-Man come back with a calf of her own. And juvenile whales are actually the most vulnerable age class of whales. And so it's particularly important that they figure out how and where to feed in order to gain enough body weight so that they can make it through 6 months of fasting on the winter grounds and then make it back to the next summer healthy and strong. And Pac-Man is actually really smart because she seemingly figured out a great way to do this, to learn how to find food and how to gain weight. And the way she does this is by copying other older, wiser whales. So this whale that you see that just took a dive on the right is a male whale called Peak, who's about 40 years old. So he's an old whale. And what you can see here is he just did this thing called a bubble blast, where he released air out of his lungs, essentially. And then he did this big jaw snap where he opened and closed his mouth. Now you can see much smaller Pac-Man heading over to exactly where Peak is, and look what she does. She does a bubble blast, and then she opens and closes her mouth and snaps her jaw the exact same way that Peak did. And just this short clip is suggesting that Pac-Man might be copycatting other whales that she spends time with. She might be piggybacking off of other older whales that have been using these feeding grounds for much longer than she has in order to teach her how to do these different feeding tactics. And Peak and Pac-Man aren't the only time where we've seen Pac-Man sort of copycat and spend time with a lot of older whales. So I think it means that Scarlett has taught her daughter Pac-Man to be really, really resourceful and know where to go when you need to learn something. The next success story I want to tell you about are about Clouds and Cheetah. Clouds and Cheetah are another mom-calf pair that we documented. So the whale you see at the top here, which is really dark, except for some of these sort of white stripes that maybe look a little like clouds, is the mother, and Cheetah, who has this kind of mottled pigmentation, is her son. We documented Cheetah as a calf in 2016, and we have since seen him come back to the Central Oregon coast every single year, suggesting that he too learned from his mom clouds that coming to the Oregon coast was a really good life choice to make. And what you see here on the left are two drone images of clouds. On the left here is actually when Clouds was still lactating and still weaning Cheetah. So you can see she's pretty slim compared to this image on the right, which was taken a few months later when she and Cheetah had separated. Cheetah was fully weaned. He was now out on his own, and she had started to gain that critical weight back. And that's sort of reflected here in the body condition data. So it's really cool that in 2016, basically after we documented Clouds together with Cheetah when she was still weaning, we saw her 3 more times after when she and Cheetah had separated. And you can see how quickly, I mean, in 2 months, she gains a whole lot of weight between this red point and the gray point. Which just shows how rapidly these whales can gain weight when they need to and after they've been in this really stressful period. Since 2016, we haven't documented Clouds with another calf, but her body condition has still sort of gone up and down, but remained fairly consistent over the last few years. Okay, so far I've talked about a lot of female whales and their calves, so I think it's time to introduce you to one of our most well-known male whales. Figuring out who a whale's father is almost impossible unless you have a lot of genetic data, which unfortunately we do not have. But if I had to make a guess, I would say that this whale, Orange Knuckles, is definitely the father of at least a few PCFG gray whale calves, since we've seen him multiple times attempting to court several females on many different occasions. He got his name because the first year we saw him, which is when this photo was from, his knuckles, which are these ridges along the back of a whale, were really bright orange. And the orange color comes from something called a cyanid, which are whale lice. Sounds kind of gross. I think they are a little gross. We believe that these whale lice hitch rides on whales in order to eat their dead skin. Yeah, like I said, kind of gross, but we see them a lot in different wounds on whales. For example, Scarlet's wound is so orange because all of those little orange things are whale lice. Interestingly, though, these whale lice, they're not always there. For example, this year, so the bottom photo is a photo of Orange Knuckles this year. You can see that there's hardly any orange cyanids in his knuckles. So clearly, cyanids move around, maybe they fall off, look for another whale. We're not really very sure what the relationship is between whale lice and gray whales, only that we find them typically in wounds, and sometimes they appear and sometimes they disappear. Now, those of you with keen eyes will have perhaps noticed another orange patch on Orange Knuckles' body. This is a scar actually from an implant tag, which was attached by another marine mammal research group here at Hatfield Marine Science Center, which was headed by Dr. Bruce Mate. So unlike the suction cup tags that we use in the Gem Lab, these implant tags can stay on a whale for weeks, sometimes even months, and they provide long-term tracking data of individual whales. Unfortunately, because they implant into the skin, they do leave scars on the whales. And so there are about 20 whales, 20 gray whales that you might see from time to time that have these orange circles on their bodies. If you see that, it's probably from a tag scar from one of these implant tags. So now if we look at Orange Knuckles' body condition over time, we can see that it's much more consistent than that of female whales. If we ignore this little dot up here, which is kind of high and kind of weird compared to the other ones, probably an outlier, generally the body condition of Orange Knuckles hovers around 24 to 26. Now, this is pretty common for mature male whales. It's because unlike reproductive female gray whales, males tend to have much more stable body conditions across years because they experience less variation in their body condition, because they don't have to produce a calf, care for the calf, anything like that. Instead, their body condition changes are mostly influenced by the weight gain or loss related to their nutrition. So when they arrive on a feeding ground, for example, here in 2018, they're skinnier than by the time that they leave in most cases. Okay, and to wrap it up with possibly the favorite and most famous gray whale, at least in the Gem Lab, I want to talk about Soleil. She is a true Oregonian gray whale. I think she deserves an Oregon driver's license. Just a joke. But anytime we go out on the water looking for whales, 90% of the time we are guaranteed to find Soleil. She even has basically one kind of favorite spot on the Oregon coast, but to be respectful to her and her space, I won't reveal where it is. I'll just say that it's closer to Hatfield Marine Science Center than it is to Depoe Bay. And because we see her so often and she's so reliable, she really is the superstar of all of our data sets. We've seen her the most number of times. The number of fecal samples we've collected from her over the years is about 30, which is a lot, given that we have to, wait for the whale to poop to collect one of those. And we've flown over her with the drone more than 40 times. So she definitely leads the scoreboard in each of the categories of the data that we collect. Now, Soleil's body condition plot is really interesting to look at. First of all, we saw her so many times in 2021, all these dots here on the right side of the plot, that we were really able to capture her progressive weight gain over the entire summer. Most whales we see once, twice, maybe 3 times, but we saw Soleil so often that we were really able to see where she started and where she ended at the end of the summer. Another interesting thing about this chart is how high her body condition is at the end of the 2019 summer feeding season. In fact, this value is almost just as high as Scarlett's body condition value when she was pregnant with her calf Rose in 2019. And so this really high body condition value leads us to believe that Soleil may have been pregnant during the 2019 summer. Unfortunately, we didn't see her come back in 2020 with a calf in June. And again, as I mentioned before, that could be for a number of different reasons. Either she had the calf and weaned it before we were able to see her with it, or she had a calf and it was attacked by killer whales, unfortunately, and died, or she was pregnant and then made the decision not to carry out the pregnancy, but to terminate it because she maybe wasn't as fat as she wanted to be in order to basically give birth and care for her calf. And so that's it for story time. But before I go, I just want to make you aware of a resource that we have put together in the lab. It's a website called MCWC. If you've heard about it before, great. If you haven't, please go visit it. Please tell your friends about it. A lot of what I talked about and shared with you tonight is on MCWC, but the website also contains lots more stories and sort of life stages of a lot of different whales. Also, a really great resource is that we have a couple of pages all about gray whale watching from shore. We talk about the best times and places to go on the Oregon coast, as well as explain some of the different behaviors you're most likely to see and when. And the final page that I'll highlight is our newest feature, which is a place for you to submit photos of gray whales that you've maybe taken along the coast. We provide some pointers about what makes a good photo, but if you submit a photo and we're able to match it and identify it, then we will provide you with any sighting information, name, age, where that whale's been seen and how often on the Oregon coast, any information that we have on that whale. And it's great for us because we get a new data point for our research. We're not able to be on the water every single day. That would be way too exhausting, but I'm sure you all spend a lot of time looking at the ocean, spending time at the coast. So if you have photos, please submit them. if you don't have photos, go to Individual Whale anyway. There's lots of great stuff on there. And with that, I will end my talk and take any questions if you have some. I also have my email address here, so if you have any other questions, feel free to reach out. And at the bottom there, the third website is the link to the Individual Whale page. So yeah, thanks for having me, and I'm happy to take any questions.
Sweet. Thank you so much, Lisa. Wonderful presentation. Many accolades in the chat. I will go ahead and read any questions aloud, starting from the beginning, and feel free to throw any other questions anyone has in the chat, and we'll get to as many of them as possible. So, first question is, Bill Montgomery was wondering, have you and the team found significant or disturbing microplastics data in your samples? Thanks.
That's a great question, Bill. Yeah, that work is currently under review by other scientists. And it's a little tricky to do because basically the way we collect these fecal samples, as you could maybe see in that video, gray whales, when they poop, it's not like one contained poop. It's more of like lots of tiny little particles that are almost like a cloud in the water. So when we collect it, we're swishing our nets through the water, which means that we're not only collecting, the poop, but we're also collecting whatever is in the water. So it's a little hard actually to know exactly from the whale poop what or how many microplastics there are. To sort of get around that problem, what we did is we analyzed the prey, and we looked at how many microparticles were in the prey. And then sort of extrapolated how much was in one prey item to sort of the energetic needs of a gray whale. So, calculating if a whale needs to eat X amount of this prey, then it theoretically is consuming X amount of microparticles. And I'm sad to report that the numbers that we found were really, really high. We had estimates of between 8 to 15 million microparticles a day being consumed by gray whales. So it's a lot, seemingly, based on what was in the prey. We don't really know, though, how it might be affecting them. I mean, they might be small enough that they just pass straight through, or there might be sort of long-term effects of ingesting this many microparticles. So that study that we did is sort of very preliminary. It's the first look at that. And there's another research group here at OSU that's going to sort of carry that work forward, working with Lee. So stay tuned for updates, but unfortunately the estimates are really high.
Debbie Pickering was wondering, are the BAI box plots, I think the ones from pretty early on, are they statistically significantly different from each other?
That is a great question. Not all of them, but yes, the sort of the highest and the lowest are. So wait, maybe I'll just quickly go back to that slide so that what I'm saying makes sense. Yeah, so your 2020 and 2021 and 2017, they are statistically significantly lower than 2016 and 2018.
Sweet. Thank you, Lisa. A question from Betsy. She asks, has there been any progress in the development of ropeless technology to eliminate entanglements? And if anybody has any answers to that might know about fishing too, feel free to spend in the chat. But I'll pass that over to Lisa. Thanks.
Yeah, that's a great question, Betsy. As far as I know, and this isn't really what I specialize in, but as far as I know, ropeless technology has been more at the forefront on the East Coast with the lobster pots associated with the North Atlantic right whale entanglements. And I think the status of that is basically they're that the technology exists, it works, but that it's really, really expensive to make still. So it's basically unaffordable for fishermen, as far as I know, for lobster fishermen to basically, you know, switch out all their lobster pots for this ropeless gear. I think a bit of a standstill is that it needs to be subsidized by government agencies or you know, sort of investors to make that technology more realistic. And I've also heard that it's sometimes not entirely reliable. So the way it's meant to work is you sort of trigger the pot with an acoustic release. And so you have, I don't know, some sort of an app or a button or a device that you press, and then the pot is meant to disconnect and meant to float up. But I've heard that it's not 100% reliable. So it's being worked on, but I don't think we're at the stage yet where we can just swap out all the current gear for ropeless gear, unfortunately.
Very cool. Thank you. Got some accolades, great format and presentation, and so grateful you guys are doing this. Amazing presentation, great presentation, fabulous presentation. And then Debbie again asks, have you seen any changes in what they are feeding on over time, or do you not have enough samples yet to tell?
Yeah, so that genetic prey work that I talked very briefly about from the fecal samples is being conducted by another student in a different lab here at the Marine Mammal Institute. And genetics is not my forte, but again, from what I understand is that it's not as, I always thought that it was as simple as we collect the poop, you know, we check for the different prey genetics, we know what we got, and we know how much the whale was eating. Unfortunately, it's not that straightforward. There's a lot of noise in there too. Basically, there's a lot of DNA in just the water. So again, when we scoop up all that poop and we're scooping water too, we're getting a lot of different signals, and it's hard to know what is it exactly in these genetic signals that is direct prey of the whale, or what is just kind of background noise that just happens to be there too. So again, it's a work in progress. We do see species in there that we know for sure these gray whales are targeting, but whether or not there's sort of changes or fluctuations in what they're eating on a yearly basis, we're not quite there yet, but we're working on it.
Awesome, thank you. Couple more questions here. John is wondering, are you guys working with the state about the plan to deploy wind generators along the Oregon coast as a potential harmful impact?
Great question. So that is a little above my pay grade. What I can say is that the Marine Mammal Institute was awarded a very large grant to research basically the distribution of cetacean species as well as seabirds along the entire West Coast, to then look at where there would be potential conflict or overlap between cetacean, seabirds, and wind energy. So that is a huge project that almost the whole institute is involved in. It's headed by our director, Lisa Balance. And so, yes, there are efforts within the Marine Mammal Institute, but I am a little too low level to be involved. I believe there's a website about it. The project is called Mosaic. I'm not going to remember what that acronym stands for. I'm sorry, but if you Google Mosaic Marine Mammal Institute, OSU, it should come up. And that project is in the works.
Very cool. Thank you. Let's see, we'll have wrap it up with these last two questions. There's some pretty interesting discussions in the chat going on about those ropeless pots ranging from biodegradable ropes and various articles associated with that. So check that out if you are not on the chat yet. But a question from Fran. Fran says, very nice presentation. Do you have cards that advertise Individual? Because she would like to get them to the Depoe Bay charter boat businesses and encourage photo submissions.
don't, but I think that that is a very good thing for us to work on. So I might talk to Lee about it and get back to you, Fran, about doing that, because I agree, having something physical to pass out the website is sometimes a little easier than just telling people a URL.
Sweet. And I guess we'll wrap it up on this question, a fun one, maybe. Well, maybe not. I don't know. From Paul, back to the story time, but he was wondering if you heard talk about the interaction with an entangled whale and a diver off the Central California coast.
No, I have not heard that story. I don't know if Paul can unmute himself to tell us that story.
Goes to show there's more stories always to be told and made.
Always. I'm sure everyone in the audience has a gray whale story or two.
Awesome. Let's see if I can get Paul unmuted here.
Hello.
You're good.
Good. Hey, great talk. Excellent. Well, the story is on a radio lab, and it is humans and species interactions. That's what the radio lab is about. And it had to do with an entangled whale that a boat operator saw, sent a word out, I need some help. The whale looks totally stressed. A crab pot is dangling from it, and it looks out of breath. And so he put the word out. Some divers came up and then figured out a way to. They all got in, and the divers said, "I looked right into the eye of this whale and had to use my knife to cut the rope free."
Wow.
And he saw the pot drift off into the deep. The whale took off and then turned around and came back, looked him in the eye again, and then nudged the diver.
Wow.
It was really good. You could probably Google that up. Radio lab, human species interaction, and it's multiple stories about it. It's really, really good.
Cool. Thanks for sharing that, Paul. Yeah, Radio Lab has done some awesome episodes, other ones too, about whales. I will say about that story, it's very lucky that nothing happened with the divers. I think obviously it's a huge success story, and that made me really happy to hear that they were able to cut the line and the whale got free. But I would say especially NOAA probably cautions not to do that, because I think the risk to humans is pretty big. If a whale sort of, freaks out or moves its peck or its fluke, it can probably mean death to some humans. But thankfully that story went well. So yeah, I'll have to check that out.
Yeah, maybe I can find the link and I'll send it to Tom. And there's another one related to whales and dealing with orcas, whales against and orcas, and predation on seals and sea lions. I don't know if you heard that one too. It's really.
I think I've heard that one. Yeah. Yeah. They produce some really good episodes on Radio Lab.
Thank you very much.
Yeah. Thanks for sharing.
Awesome. Well, I think that's pretty much it for